Hello friends, this is Dr. Antoine Niungeko, your coach in data analysis using R tool. In this video, I'm going to show you how you can compare frequencies from a contingency table when you have, for instance, a group of people who has to answer the yes or no, good or bad. And here I'm going to show you how you can test whether the conditions of using one test are met or not, because when conditions are not met, you have to find the correct test to be used so as to decide whether there is a significant difference between your proportions or between your percentage. Remember, when you use the chi-square test, the null hypothesis is that the proportions are equal when you use a two-sided test, and the alternative is the proportions are different. And when you use one-sided test, the null hypothesis that is the proportion, the percentage 1 is equal to percentage 2, or you can use the alternative may be the percentage 1 is greater than percentage 2, or the percentage 1 is less than percentage 2 or proportion 2. Well, what are the conditions to use chi-square test? All expected values must be greater than 5. In here, you can use this chi-square test. How you can write a chi-square test? This is the contingency table, and you add here correct equals false. This is the comment. This is the contingency table here. If there is expected value which is less than 5, chi-square test is used together with Yates correction, or you can use Ficher Exact test. You can use this is the comment when you use the Ficher test, and this is the contingency table. Or when you use chi-square, you use this comment, this one, this comment, and this is contingency table. When the sample is paired, you can use Mc Nemar test. When all paired are greater than 10, you can use this comment. But if paired are less than 10, you can use this comment like this. And this is contingency table. I'm going to follow the example given by data, and these are the data used in the presentation. I'm creating the matrix of data as you see here, friends. I'm going to create the matrix. We suppose that we are going to make a contingency table. This is how you can make a contingency table, and the final table, we get this kind of table. As you see here, we have this female who has no ulcer. We have this number, and the female with this ulcer, we have this number, and the male with ulcer, with no ulcer, we have this number, and the male with ulcer, we have this number. Here, for the problem, the kind of question we want to answer is that the number of female, or the percentage of female who has ulcer is greater or is equal to the percentage of men who has ulcer. Okay, now the table we have here. Now you see the table we have here is this table we are creating. Now, as you see here, we have don't have or have, and here we can just plot our data. Look, friends, when I want to make a simple plot, I can do like this, but I can just do another plot like this. And here we want to compare using chi-square tests. If we want to compare the proportion of men and women with ulcer. Now here, this is the comment. Look, friends, here. Now, as you can see here, the p-value is less than 5%, and we can say that the proportion of women with ulcer is statistically different from the proportion of men with ulcer. Now let's check the expected value if they were equality. Look, friends. If they were equality, for instance, now look here, friends. You will have female with no ulcer, this number, and women, female with ulcer, this number, and so on. But yeah, this is the expected values. Now we can calculate to see if the correlation between gender and the fact that of having such a ulcer. We can use this correlation. But as you can see here, the relationship is small, or correlation is negligible. And here there is a conditions. Expected value, look, friends, when we check our expected value, as you can see here, the expected value are greater than 10%. But the second condition is that expected value, expected value must be greater than 5%. The second condition is that when you use chi-square test, expected value must be greater than 5. Now look, for instance, let's create another data frame or data set. This is another data set we are creating, and here we can also plot. Let's show you how we can plot this. We just to copy this and we replace our data. Here we replace our data like this, friends. I put here 1, and we are going to see how this can be plotted. Look, friends, this is the, I can just reduce the limits. I can just put 11 here. Look, friends. Okay, now it's okay. Now, the second condition is that expected values must be greater by, the second condition of using chi-square test is that the expected values must be greater than 5. Now, as you can see here in this data set, now these are the values. Like when I print, look, when I print, sorry. Now we have, for instance, situation like this. Look, friends, here we have a situation like this. You are conducting your study and you find we have a situation like this. And let's see if you can use chi-square test, or if you can use collection of your raw data. This is the chi-square test applied on this data set. Look, friends. Sorry. Okay, now as you can see here, this is the p-value. As you can see here, the p-value is greater than 5%, and we cannot reject the null hypothesis of the equality of proportions or frequencies, proportions. Even though we have this test, we must check when you look on the warning, for instance here, look on the warning here, warning message in chi-square tests, l'approximation de chi-square est peut-être incorrect. This is indicate that the approximation may be incorrect. Now we must check why this error. We must check whether the expected values are greater than 5, as it is in the condition, the second condition. Now we can look expected value here. Look, friends, here. Now here, the expected value, as you see here, it is. Let's delete all this. We check our first look when we learn these tests. Let you see the message, warning message. This is the warning message, and that the approximation of the chi-square test may be incorrect, and we want to know why we have this warning message, and we look on expected value here, which must be greater than 5. And as you see here, friends, expected values are here are less than 5. That's why we have a warning message here. And as we have to continue with our study, we must find another test which can be applied when the condition of applying chi-square test are not met, and we use this correction. Now let's run this command, friends, here like this. Here also we have let's run these tests. Look like this, for instance. As you see here, we have a correction. We use a correction because the conditions are not met. Pearson's chi-squared test with Yates' continuity correction. That is the correct test that we have to use, because the condition of having expected value greater than 5 is not met. We have to use this comment, this one, and we can conclude that our proportions are not statistically significant as the p-value is greater than 5%. We can also use a Ficher test when the conditions are not met, when the conditions of using chi-square test without correction are not met. We can use this Ficher test, and let's see the result from Ficher tests. As you can see here, the p-value here, as you can see here, friends, it's greater than 5%, and you can conclude that there's no significant difference between two proportions. Now, we have been working on independent sample, but what is the case? Which kind of test you can use? As you can see here, friends, we were working on independent sample. But what kind of test you can use when the sample is paired? When you ask, for instance, 2 times same group, what we call a paired sample test. What kind of test you can use to check whether proportions are equal in case of paired sample? Now you can use this test. Mc Nemar test, it can be used here. And I continue to do the same. I create my matrix. You will see the matrix here. Remember the same, the null hypothesis is that the proportions are equal. Now I run this test of Mc Nemar. Now, as you can see here, the p-value is less than 5%, and they conclude that the proportions are not equal. We can also use corrections, and also Mc Nemar has conditions, and I'm going to show you how to test whether the conditions of using Mc Nemar without correction are met or not. Now let's suppose this is a new data frame I'm going to create. You will see the result of our new table we can have here. Let's delete all this. Let's run this test. Now look, let's reduce this space here so as to. Now let's run this test. Okay, you see here now, friends, you see what we have, the result we have. You see the table, and the problem with this is that this number in Nemare test, this number plus this one must be equal or greater than 10. This is the problem of this table we have when we want to use Mc Nemar test. And in that case, when you have such a situation, we must use correction. And we run this test like this. but like this. Okay, friends, when you, as you can see here, when you learn this test without correction, look here, friends. Look at when you learn this test without correction, look on the p-value. You see the p-value is this one. But when you include correction, look on the p-value here. As you can see here, the p-value is greater than the first one. And as you see here, friends, this is how you can analyze the frequencies. And what I can tell you, or what I can advise you, it is better to know to analyze the data you have and look when you want to apply a test. Look if all conditions are met to apply that test. In case of conditions are not met, try to find an appropriate test that you can use for analyzing your data. This is the end of my presentation. Thank you for watching this video, and I invite you to subscribe to my channel, and thank you for watching. For next video, bye.